Now we're going to cover 7.1b of the notes, and it deals with inscribed angles in a circle. So our objective for this part of the notes is to define an inscribed angle and use the inscribed angle theorem to find measures of arcs. An inscribed angle is an angle whose vertex is on the circle and whose sides each intersect the circle in another point. So in this case, B is the vertex on the circle, and the side AB intersects the circle at point A, and the side BC intersects the circle at point C. Inscribed circle. We are going to find the measure of an inscribed circle here. Find the measure of BAC and circle A. Okay, so how could we go about finding the measure of angle BAC? How could we find that? Bryant. Okay, so we would get, that's going to make this 140, right? Then how do we know BAC? How can we find BAC? Okay, anybody know how we would find BAC? We've got that one angle is 140. What can we do next? Yeah, go ahead, Mia. Yes, it's an isosceles triangle. These are both radii, so they're congruent. So what does that mean about those angles? What would they have to be? Okay, so you get minus 140 from 180, you get 40. So are they both 40? What are they? 20, right. We divided by 2, so they're both 20. All right? Now, we could go through that process every time we had to find an inscribed angle if we knew the central angle, but an easier way, I mean, we can just make a rule, you know, in this case, like angle BAC, okay, that's the inscribed angle, is equal to half the arc BC, you'll notice. That intersects. We know the arc BC is 40 because that's the central angle. So it's going to equal 1/2 of 40 degrees, which is equal to 20 degrees. That's always the case with the inscribed angle. So our inscribed angle theorem says that the measure of an inscribed angle in a circle is equal to half the measure of its intercepted arc. So here's arc AC. Angle ABC is going to be half its measure. Half its measure. We're going to prove the inscribed angle theorem. We proved it with numbers. Now we're going to prove it with a proof. Okay? So there are 3 cases. We talked about cases at the beginning of the chapter, that 3 ways to approach a problem with 3 cases. So we're given angle ABC as an inscribed angle in a circle. We're going to prove that angle ABC equals 1/2 of arc AC. The 3 cases to consider. Where the center O is on CB. Okay, that's not what's in the picture, but the center O could be on the segment CB, where O is outside of ABC, or where O is on the interior of ABC. We're going to do, let's prove C. we'll do the proof of C, where O is in the interior of ABC. So the first step we would do is we would draw a diameter BD through O to intersect the circle. So we would draw diameter BD. Okay? Then we know from the inscribed angle theorem that angle ABD is equal to 1/2 the arc AD. And we know from the inscribed angle theorem that angle CBD is equal to 1/2 of arc DC. So we can use the angle addition postulate and say angle ABC is equal to angle ABD plus angle CBD. And then use substitution from the sentence before to say that that equals to 1/2 arc 8 AD plus 1/2 arc DC. And that equals to, we factor out the 1/2, that equals to 1/2 of arc AD plus DC. And then by arc addition, we know that that equals to 1/2 of arc AC. All right. Any questions? You may have to prove A and B in the homework. I can't remember, but I think you might have a homework problem where you have to prove A or B. All right. Everybody have it written down? Okay. Example 7.9a. Find x. How would we find x in 7.9a? Well, listen. What will we do? Okay, we're going to use the inscribed angle theorem. So what does x equal half of? Anybody see what we need to do here first before we figure out x? What do we need to do? There's a pre-step. Jake? Label it? Yeah, it's not necessary to label it. What do I need to do? Anybody see? Okay, so we need to know what this arc is. Right here. How can I find that arc? Julie?
Subtract the other arc pressures.
From?
360.
360, right. What is that going to be? 360 minus 250, Bryant. Yeah, it's 110. So is x 110? What is it? Right. It's half of that. X equals 1/2 of 110, which equals to 55 degrees. Okay, very good. Now, find y in figure 7.9b, where O is the center of the circle. Okay, so this time we're given the inscribed angle. We have to find the central angle that corresponds to that. What would y be? Chris? Yes, it'd be 40. It'd be 2 times 20. So in B, we've got y equals 2 times 20 degrees, which is equal to 40 degrees. All right. Any questions? Okay. Corollary 7.2. Inscribed angles that intercept the same arc or congruent arcs are congruent. So that's saying that, okay, so we've got this arc CD is inscribed by both this angle and this angle, right? They both inscribe that arc. So these two angles are going to be congruent. B and A. Angles CAD and angles CBD both equal half of arc CD. Right? Okay, now what the common misconception on this is, people think that they do it like they say that this angle. We've got to go back. They will say this angle and this angle are the same. We don't know that. It's not. Those aren't alternate interior angles because these two lines, this line and this line, are not necessarily parallel. If they were parallel, then you could say these two angles are congruent. They both, you could say they're congruent. But it's not. We don't have that situation here. We just have. What we have is these two angles being congruent. Yes, Sam.
I was going to ask if you knew those angles, and you knew, if you use vertical angles for also, I guess A, D, B, usually you can figure it out. But
Vertical angles. Okay, these are vertical angles here. So
you knew those, and you knew, I guess, angle D, A, C. Did you figure it out?
well, we don't have congruence there. The triangles aren't necessarily congruent. If that's is that what you're getting at?
Kind of,
Yeah. We don't know if the we don't necessarily know congruence. We could say they're similar. They're similar, but that's because these two angles match up. All right. So here's just a quick proof of that idea. We're proving CAD equals CBD. By the inscribed angle theorem, we have CAD equals half of CD, and CBD equals half of CD, therefore they're equal to each other. Corollary. An angle is inscribed in a semicircle if and only if it is a right angle. So the if and only if also means that if we have a right angle, we know it inscribes a semicircle. Makes sense, right? Because, let's look at the proof of it. Given ABC is inscribed in a circle, we're going to prove A. If ACB is a semicircle, then C is a right angle. The proof of that's below. If ACB is a semicircle, then ADB is a semicircle. This is a semicircle. Because the arc of a semicircle is 180, then the inscribed angle C would equal half of that. It would be 90. Then if we prove it the other way, if C is a right angle, then it intercepts an arc whose measure is twice that, so ADB would be 180. So ADB is a semicircle, and ACB would also be a semicircle. It's the other half of the circle. Questions? Okay. Example. Find the measures of the following angles in the figure, where O is the center of the circle, and AC and DF are diameters. That's key. Whenever you're doing one of these problems like this, identify the diameters, because that can tell you a lot. You know, you've got 180 or whatever. If you get stuck, you're probably missing a diameter, identifying a diameter. You'll see what I mean when we do when we solve this problem. Okay, so what would COD be and why? COD, what is COD and why? Eli, what's COD going to be? Angle COD. Why? It's a central angle, right? What about the arc that it intercepts? No, it doesn't intercept the diameter. It intercepts this arc, right? It's a central angle. What do we know about the central angle and the arc it intercepts? Bryant? Yeah, they're the same. It's the same as the arc it intercepts. Okay, angle B. What would angle B be? Right? Well, how'd you get that, Bryant? Yeah, AC is a diameter, so that means that if B intersects the the endpoints of the angle B are the diameter that's going to intersect an arc that's 180. So B would be 90. All right. What about angle C? What's angle C going to be? Let's see. Gabby, what would angle C be and why? Morgan.
30 because
Right. It intersects. Angle C intersects a 60-degree arc, and C is half of that, so it's 30. All right. Angle DAB, DAB. What would angle DAB be? All right, so this one is a little more challenging. So we would have to say we would have to use the diameter idea. Okay, knowing DF is a diameter, what do we know that CF is? Megan. If DF is the diameter, what do we know that CF is? No. AJ. How'd you get that, AJ? Yeah. DF is the diameter, so this part of the circle would be 180. So we had that was 120. So the rest would be 60. Okay, so we've got DF. Now we have to do how can we find BF? Again, use diameters. How can I find BF? This time we know AC is a diameter. Eli.
Since you have where AB is 60 and CF is 60, then you know BF has to be 60 to equal AB.
Yes. Because of this diameter, we know that this is a semicircle. And we had this was 60 and that's 60, so what's left is 60. Okay? So then we've got everything we need to find. Let me clear this out and make it more clear. So we've got we were doing angle DAB, right? Which is this arc. And we determined that this was 60 and this was 60, right? So what's angle DAB going to be? Right? How'd you get that? Right. Okay, he added the numbers with the around the yellow arc. 120 plus 60 plus 60. That's 240. Divide by 2. DAB equals 120. All right? All right. What about angle D? What would angle D be? Adam, angle D, what's it going to be? How'd you get that, Adam?
Because BF is 60.
DF is not 60.
BF.
What's that?
BF.
But it doesn't inscribe BF. It angle D inscribes this arc right here. That's what angle D inscribes. Is the inscribed angle the same as the arc it intercepts? What's the rule? Inscribed angle is what the arc intercepts? It's half. It intersects 120, 60 plus 60. So you got lucky. Half of 120 is 60. Okay, you need to get good at these circle problems. Okay, you'll do a lot of them, and some of them more complex than this. Okay, so get good at them. And remember, if you're stuck, look for a diameter. And then you can subtract angles from the 180 to figure out missing angles. But that's key. Look for a diameter if you get stuck on these circle problems. Any questions on the notes? Okay.